Hello friends, welcome to another session of video tutorial on Java. Please subscribe to my channel. To subscribe to my channel, click on the subscribe button and then click on the bell icon so that whenever I post a new video, you get the latest updates. In today's session, we are going to cover data types. Under data types, we are going to cover primitive and non-primitive data types, and also we will cover typecasting. Implicit and explicit typecasting. Okay, so what is a data type? Okay, the data type tells the compiler which type of data is being stored in that particular variable. Let us assume that there is a variable called var1 and it is of type integer and it is storing value, so for example 12. So we declare this as int and the name of the variable is equal to 12. Since integer is of 4 bytes in Java, so that means the first byte, second byte, third byte and fourth byte. Okay, so this is first, so this is second, this is third, and this is the fourth byte. Okay, so how does the value get stored into these? As we know that it is storing it in zeros and ones. Okay, so this byte will again have 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. 12 is nothing but 1, 1, 0, 0. Okay, so this is, so this will be 0 and this will be 0, this will be 0, this will be 0 and 1, 1, 0, 0. So this is 2 raised to 0, this is 2 raised to 1, 2 raised to 2 which is 4 and 2 raised to 3 which is 8. 8 plus 4 is 12. So all other bytes will be as zeros. Whenever we declare a variable var1 of type integer, it tells the compiler to allocate 4 bytes of memory to store this particular value, and this is how it stores the value in 4 bytes. Whenever I say these data types, integer, float, double, short, long, char, boolean or byte, these are all primitive data types. Primitive data types are those data types wherein the memory allocation is fixed for these type of data types. So there are different sizes being allocated whenever we declare a variable of these types. Non-primitive data types are those types which are nothing but objects wherein there is no specific memory size being allocated for these kind of data types. Primitive data types has got a specific size of memory being allocated for each different data types, wherein non-primitive data types will not have a specific size allocated for these data types. Okay, the examples of non-primitive data types are objects. So let us see an example of this. So here I'm going to create a new class and I'm going to call this as data type data types and click on main. Okay, finish. Okay, so how do I declare a data type? Okay, int is equal to 10. Okay, so this is declaration and initialization. Okay, if I say int var1, then this is just a declaration. When I assign some value to it, then it is declaration plus initialization. Okay, let us see how to declare different types of data types. Okay, and now float declaration, float long char double so boolean This is how you declare and initialize the values for different data types. Okay, so let us print now. Okay, sys out and control enter will give you system.out.println. So let us print one by one. Int var so I'm just putting some space in between. So this is a concatenation operator. Plus will concatenate two strings. Okay, flt var plus n plus plus So the last one will be multiply. Okay, so here I'm just printing the values. Okay, so let me run this. Right click, run as Java application. Okay, so you can see there is 10, which is int var 10.2, and the character is displayed as a 100.234 true, 5 and 3. One thing to note here is these primitive data types in Java has got its own wrapper classes. For example, integer is a wrapper class for primitive type int. The same way, long is a wrapper class for long. So if you don't know what is the maximum value a particular data type holds, you can always make use of these wrapper classes to find out what is the maximum and min value. For example, okay, so integer dot min value and plus integer dot max value. Okay, so if I run this, it should give me the max value and the min value. So the minimum value is this and the maximum value is this. As an integer variable, it can only store the values between these two numbers. Okay, the same way I can change it to long. Okay, I will print both. Okay, so let me run this again. Run as Java application. Save this. Okay, as you can see, integer can store values between these two numbers, and long can store bigger values. Okay, so this is one way of finding. Okay, so this is one way of finding how big the values can be stored for a particular variable of specific data type. Okay, this is one way of knowing what from this you can define how much data can be stored for a particular variable of a specific data type. Okay, so long can store bigger values and integer can store smaller values. So by making use of wrapper classes main value and max value, you can find out what values that particular data type can store. Okay, so let us move on to typecasting now, implicit and explicit. So what is typecasting and why do we need it? As we have seen earlier, that long can hold bigger values and int can hold smaller values. So if we are converting from integer to long, since long can hold bigger values, we don't have to explicitly typecast it. That means we need not have to explicitly convert that integer value to a long value. That means compiler knows that integer value can fit into a long. So compiler will convert it automatically from integer to long, wherein the other way around, if we are converting a long into an integer, since long can hold bigger values and int has got capacity to store only smaller values. Since there will be some data loss, so we need to explicitly tell the compiler that I am trying to convert it from long to integer. So in that scenario, we have to explicitly tell the compiler that I'm trying to convert and I'm going to compromise on the data loss. So that type of casting is called explicit typecasting. Let us see an example. Here, long var is equal to int var. Okay, so this conversion is implicit, wherein if I say int var is equal to long var, then I get an error here saying that you need to add a cast here. So how do I cast it? By providing integer var. Okay, so this becomes explicit. You can see the difference here. Integer value can easily hold under long, since long has got a bigger space. When I try to fit in the long into integer, then there is some data loss involved. So that data loss we have to explicitly tell the compiler, okay, I'm trying to change the data type from one type to another type and I'm okay with the data loss. That is called explicit conversion. If you are converting from a smaller to bigger, that is implicitly handled by the compiler. But whenever you are trying to convert from bigger to smaller value, then you have to explicitly tell the compiler by typecasting it. So this is what typecasting is. Now let us print the value after it is being converted. Long var as some space plus int var. Okay, so let us print this. Nice. Save this. The value of int var is 10. This long var has got value 10 now, so that is what is being converted back here. Instead of that, I'm going to have another long value here. Long var1 is equal to 500. Okay, so I'm going to convert this into this. Okay, so let me rerun this. I take a nice Java application. Okay, as you can see, 500. Since there is no data loss here, because 500 is small number which can fit into an integer. If it is a long number, then we might see some data loss. That is about the data types. This is how we can make use of different data types, and the variables can be assigned with a different data type. We will see non-primitive data types when we come to classes and objects. That is the end of today's session.